Hey y'all, in this video we are going to look at solving systems by graphing. So our I can statement is I can find the solution to a system of equations using graphs. Reminder that a system of linear equations is formed by two or more linear equations that use the same variables. A solution of a system of linear equations is any ordered pair that makes all equations in the system true. Our first example, we're going to solve the system y equals x minus 4 and 2x minus 2y equals negative 2. We want to graph these equations, but before we do that, we want to first rewrite our second equation in the form of y equals mx plus b. This way, we will be able to easily do the slope and the y-intercept. So off to the side here, I'm going to do that. So 2x minus 2y equals negative 2. I want to subtract 2x on both sides. I'll get negative 2y equals negative 2x minus 2. And divide everything by negative 2. This gives me y equals x, or 1x, plus 1. Now I can graph my first equation, y equals 1x minus 4, by going to negative 4 on the y-axis, and then my slope is 1. So I'm going to go up 1 and right 1 as I put my line in. For my other equation, I'm going to start at positive 1, and I'm going to go up 1, right 1 again, because I again have a slope of 1. Now what I end up with is that these lines are parallel, so there is no point of intersection. That means there are no pairs that make both equations true, so this system has no solutions. We're going to look now at the second example. In this example, again, we have two equations to solve as the system. We're going to graph the equations of the system to determine the solution. So the first one I'm going to graph easily. The y-intercept is 3, and my slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2. I like to do it a lot so I can get a nice straight line. All right, and then I will graph the other one in a orange color. So I showed you how we can change it to slope-intercept form, but we could also graph it from standard form. Remember, if we cover up the x term, we have 6y equals 18. That means that y would have to be 3, right? 6 times 3 is 18. So on y, I would have a point at 3, so the same spot. Then I have negative 3x equals 18 when I cover up the y term. This would have to be negative 6 in order for this to be 18, because negative 3 times negative 6 is 18. However, I can't graph that far over. I can't put that x-intercept all the way over. So I am going to have to quickly do what I did before. And if you want to see some extra explanation on that, just ask me. I'm happy to tell you a little bit more about that. But I can see the slope is 1/3. Oh, I messed up. The slope is 1/2. So that means I'm going up 1 and right 2. So I again have a point, and another point, and another. And it's following the same path. So I see that these equations actually are the same line. All of the pairs on each line would make them true. And so we say that this system has infinitely many solutions. You try the next two problems. Graph each pair of lines and then decide, is it a one solution, no solution, or infinitely many solutions. We'll now take a look at our final example. Lee is choosing a new cell phone plan. How can Lee use the graphs of a system of linear equations to determine when the phone plans cost the same. Which plan should Lee choose? And it wants us to explain. The system of equations that represents this is 0.20x plus 75, so 20 cents plus 75, and 0.25x plus 70, 25 cents plus 70. We're going to graph the system. So let's take a good look in here. Now we know that our first one we have is starting at 75. So here's 50, 60, 70, 75's about right there. And then we're going to go up 0.2 each time we go over. Or we could also say that we're going to go up 1 and over 5. Or we could plug in a number that's going to make it a little bit easy on us, like 100, since that decimal goes to the hundredths place, and see what that point would be. So if I plug in 100 for x, 0.2 times 100 is 20, and then 20 plus 75 is 95. So 100, this would be 90, 95. So I can graph that, and if I like my lines to be perfectly straight, which I do, I'm going to grab a ruler, line up those two spots with my ruler, and draw a line. And I missed the spot, but it's okay. The other one starts at 70, so just below there. And let's plug in 100 to see what we get. 100 times 0.25 is 25, and 25 plus 70 is 95. So we actually hit the exact same spot. Let's see if I can get it this time. Well, that's not very good. Let's see a better graph of this. Here we go. So we have company B in purple and company A in green. And you can kind of see how my black line of company A and orange line of company B looks very similar. We see that these lines are intersecting at 1 point. Because they intersect at 1 point, there is only one solution. And in this case, that solution is that point we found of 195. But what does this mean? This means that if Lee uses 100 minutes each month, both plans would cost $95, and she could choose either plan. However, if she uses fewer than 100 minutes, she should choose company B, because when we're less than 100 minutes, when we're less than over here, that orange line is below the black line. But when we go more than 100 minutes, we switch over to that black line, or in the picture here, company A, being less pricey. So if she uses more than 100 minutes, Lee uses more than 100 minutes, they should choose company A. This is how we can use graphing and solving equations in a real-world situation. There's one last problem for you to try. You have two equations in slope-intercept form for you to graph and determine what is the solution to that graph, to that system. Looks like our solution is at -1, 2. Don't forget your summary. The solution of a system of linear equations is the point of intersection of the lines defined by the equations. So when we graph them, we can see if there is one point of intersection, that is our solution. If they are the same line, there are infinitely many solutions. And if the lines are parallel, there are no solutions. Your next steps are to submit your 6.2 notes, complete your build 6.2, and then take your 6.2 mastery check. Good luck.